Section 4.8 Maximums Power Transfer. Maximum power is transferred to the load when the load resistance equals the Thevenin resistance as seen from the load. That means if RL equals RTh, the load RL will receive the maximum power from the source. And we can find it in the circuit. In the left side of terminals A and B, there is a circuit which is replaced by a Thevenin circuit. And on the right side of the terminals A and B, there is a load. RL is the resistance of the load. And RL will receive the power from the voltage source VTh. And if RL equals RTh, the load will receive the maximum power. And suppose the load is a variable resistance, so we can change the value of the resistance. So we can get the maximum power from the source when RL equals RTh. How can we get it? And we can write the power on the right side. P equals I squared multiplied by RL. I squared equals VTh over RTh plus RL squared. So we put it in the equation. And then we're going to get the maximum power. So we find the derivative of P about RL. And we let it equal to 0. And then we get an answer. 0 equals RTh minus RL. That means RL equals RTh. So when RL equals RTh, RL gets the maximum power. And what is the maximum power? We put the RL equals RTh into the equation and we get P max equals VTh squared over 4 times RTh. Actually, the power delivered to the load is a function of RL, and we can draw the graph of this function like the right side of the slide. And we can find when the RL increases from 0 and the power received by RL is increasing until RL approaching RTh. When RL is greater than RTh, the power absorbed by the load is dropping. So when RL equals RTh, it gets the maximum power. This is the end of this section.